Okay, so this one about the duct design methods. Okay, so whenever you start designing the duct design, okay, see there are many people, they used to prepare the IFC drawings or the shop drawings, right? So there is a equipment. So we have seen in the previous class how to design the equipment sizing, even if it is a fan coil unit or HU or the general fans or kitchen fans, whatever the fans, right? So we have, so far we have calculated the equipment capacity. Okay, then we are going to talk about the duct distribution. Okay, how we are going to distribute the airflow through the space by means of ducting, and there are many accessories, right? Like you have a damper, you have a fire damper, then you have a motorized damper. There are different accessories. Then you have a louver, intake louver, then you have a grills, diffusers, everything. Okay, now we are going to have the static pressure calculation for the fan sizing. Okay, so when you are going to do the fan sizing, you require two flow is very important. One is the airflow rate, another one is the head. Okay, the pressure drop, right? Okay, so now, so far whatever we have done, we have calculated the airflow rate. Okay, now we are going to calculate the duct pressure drop calculation. How to calculate? Okay, so there are, as per the design methods, okay, you can see there are different methods to calculate the duct pressure drop. Okay, there is one equal friction method, then is a static regain method, then there is a extended plenum method, T method, velocity reduction method, total pressure method, constant velocity method. Okay, then residential system design method. Okay, there are different design methods, but most of the system we are not using. No engineers will be using it, okay, except equal friction method, which is the famous, right? So this equal friction method only we are going to discuss about as per the ASHRAE. Okay, so if you go to as per the ASHRAE duct chapter, okay, you can see the duct design chapter. To calculate the static pressure calculation, you can see the formula. This is basically the duct design ASHRAE standard. Okay, if you go through the standard, you will find many equations. Okay, so we will see that which equation we will be using it for to calculate the duct pressure drop calculations. Okay, so if I go to, there are Bernoulli's equation where you can use the U-tube manometer to measure the pressure drop. Okay, when after the fan and before the fan, like you have a suction pressure and discharge pressure. So you can see the difference. What is the difference, so that you can able to calculate the pressure drop. Okay. Okay, and also if you see the method, okay, as per the equation, head and pressure method, okay, there is a term head and pressure are often used interchangeable. However, head is the height of a fluid column supported by fluid flow, while pressure is the normal force per unit area. Okay, so to calculate the static pressure, calculate the head calculation or the pressure drop calculation, this is the equation. Okay, one, you have to calculate the static pressure, that is the formula is here, P by rho G is the static head, P is the static pressure. Then there is a velocity pressure. Okay, so the velocity pressure terms V square by 2G. Okay, so this is the equation we are going to use it, right? So if you go to in shortcut, okay, to calculate the total static pressure, you are going to calculate total static pressure plus the velocity pressure. Okay, so to calculate the total pressure, static pressure plus velocity pressure. So that equation is given here, PT equal PS plus rho V square divided by 2. Okay, so to calculate the static pressure, there is an equation. Okay, you can see the different U-tube manometer, how they do the pressure drop in the ducting methods, right? Okay, if you go to calculate the static pressure, okay, there is another equation based on Darcy-Coolbrooke and Alshol-Tisel equations. Okay, so if you see this equation, you can find out the pressure drop by using this equation. Okay, 1000 FL divided by DH rho V square by 2. Okay, so this F is nothing but friction factor, depends upon the type of material. Okay, that one is directly you can get it from the ASHRAE software. Okay, so that is why I informed everyone to install the ASHRAE software, which is very user friendly. Okay, so that you can get all the information. Okay, so if you calculate other things, which is very simple, the L equal duct length, okay, the hydraulic diameter, area of the duct, or the diameter of the duct, or the rectangular duct if you have a width and height, okay, the velocity, and you can see the density. Okay, so this is all the value we can get it from software, or you can by equation you can use it. Okay, so if you go further down, okay, so this particular chart you can see. Okay, so based on the chart, based on the material, they have already defined. Okay, so if you go to airflow rate, and if you have a velocity, or if you have a size, you can able to get the pressure drop. Okay, so this is the method. This chart is developed based on that equation itself. Okay, so you can see the the density of the air, which is 1.2 kilogram per meter cube, right? And this is the material. You can see the friction factor, the material, okay, so which is called 0.09. Okay, this is based on the different type of duct material. Okay, if you go to, say for example, GI duct, okay, or mild steel duct, or MS duct, or you can go to carbon steel, or if you go to plastic ducts, okay, or if you go to stainless steel duct, okay, depends upon the surface smoothness, your value will change. Okay, if you have a more like a roughness, then your friction factor will increase. If you have a smooth surface, your friction factor will be lesser. Okay, so this depends upon the material. Okay, so you can see there are if you go to this particular chart, okay, they also given the material absorbness. If I go to further pages, there are different type of duct material is provided in the chart itself. That value can be applied directly. Okay, we will see that chart later because I'm not able to get it. Yeah, it is here. Duct roughness factor. Okay, so this is the value based on the different type of material. You can see the duct material. You have a different type of material. So this value will be normally used. Okay, so if you go to smooth duct, this is the value. If you go to galvanized duct, this is the value. Okay, so you have a different type of material. So if you go to ASHRAE standard, okay, if you go to any of the straight duct, say for example, you have a straight duct. Okay, you can see that absolute roughness, this is the value will be taken. Okay, if you are using different type of material, then you can enter the value, different value, then your pressure drop will be calculated accordingly. Okay, and if I go to in general, okay, okay, if I go further down, okay, you can see we have a different shop drawings or IFC drawings, okay, where you can see the duct routing, everything. Okay, so here by using this one, we can able to identify the path, which is the critical path. Okay, so maybe this is the critical path, or maybe this is the critical path, or maybe this is the critical path, depends upon the accessories. Okay, like if, say for example, there are some accessories having more pressure drop, so we can able to find out which is the critical path. Okay, if you have any doubt, then you can do the calculation for one path, then also you can do the verification for the other path, and you can compare which is higher, so that you can able to get the maximum pressure drop. Okay, so that is also one of the method. And if you go further down, okay, here as per ASHRAE, they have given the method how to calculate the static pressure method. Okay, so there are two accessories normally. One is the ducting and other one is the fitting. Fitting can be anything, like if you go to ducting, or if you go to elbow, if you go to elbow, if you go to say diffuser or volume control damper, whatever the fittings that is called, that will come in the accessories will come in the fitting range. Okay, and whatever the ducting, that will come in this range. Okay, so by using the ducting, straight ducting, you can able to calculate the static pressure. Okay, and by using the fittings, we can able to calculate the velocity pressure. Okay, so that you can able to calculate the total section pressure by adding static pressure plus velocity pressure, so that you will get the total static pressure. Okay, so by calculating for all the path, okay, so that you can able to calculate the total pressure drop, how much it is. Okay, and also there is another method is there, that is called velocity method, which you can able to calculate the velocity. Say for example, whenever you do the ducting design, okay, you can able to calculate the velocity based on the different application, because whenever you design the ducting system, there are different parameters. Okay, one is the airflow rate, one is the pressure drop, okay, one is the noise criteria, another one is the velocity. So these all four parameters is very important when you do the ducting design, because if you go to industrial, your velocity can be higher. If you go to residential, your velocity should be lower, because if you have a higher velocity, it will generate more noise. Okay, that will disturb when you are in a residential or in the office area. Okay, so the velocity depends upon the application, your velocity will vary. Okay, and if the velocity varies, and also your friction drop will vary, and also depends upon your airflow rate, you can able to calculate other values. Okay, so this is the method. Okay, if you calculate based on the different application, residential, or apartment or private offices or theater, whatever it is, they have given the general velocities. Okay, this is actually in FPM. If you divide by 200, you can get the velocity. Okay, but you cannot able to go only based on the velocity. Okay, you have to see the equal friction method how to calculate the pressure drops. Okay, so say for example there is one duct criteria. Okay, based on our previous project. Okay, you can see the air distribution design criteria. Okay, so this is based on the main velocity. You can go up to 7 meter per second. But not only velocity, your friction, when you have a velocity, you can also able to calculate your friction method. Okay, so do not go in a blindly that there is a velocity only as a factor. Okay, always go with the equal friction method. Equal friction means starting from the your air intake to the distribution, you can have a equal friction. Okay, so that your fan will have a better performance. If you have up and down, then what will happen? The fan cannot perform properly, right? So that is why always any engineer, okay, whoever the consultant, they used to go with the equal friction method. Okay, so if you go to verify your all the areas, like you can able to calculate the main duct velocity 7 meter per second, branch duct 5 meter per second, louvers you can go to 2 meter per second phase velocity, then the sand trap louver you can go up to 1 meter per second phase velocity. This is also value given in the ASHRAE standard, okay, for the different fittings. Okay, and if you are going for different equipment, say for example I have a fan coil unit. Okay, general you can go with 0.4 to 0.6 Pascal per meter, right? So this is the value. So when you go to 0.4 to 0.6 Pascal per meter in that range, okay, so it will be like the velocity will be constant everywhere, right? So you can go with the equal friction method, and also your velocity will be little bit not exactly the same, but it will be within the range. Okay, and also the fan performance can be better. Okay, so if you are going for other equipment like AHU or general fans, you can go up to say for example 0.6 to 0.8 Pascal per meter. Because why there is a range? Because you cannot go with exactly the same value because of the duct design. Okay, because you cannot go, there is a standard duct design, because if you go to 100 by 100 or 150 by 150 or 200 by 200, so within that range you can able to play with that velocity, or you can able to play with the friction values. Okay, that is why always go with the range. If you are going for like industrial type or kitchen or parking or smoke exhaust duct, which work very rarely, you can go with the maximum pressure drop like 0.8 to 1 Pascal per meter you can go, right? So within that range you can able to design. Okay, so if you go to calculations, okay, I have made one Excel sheet, okay, where you can able to calculate by using the formula you can get the total static pressure drop. Okay, if you have a supply ducting or return ducting, you can able to calculate the static pressure method, right? If you are going to calculate the accessories like elbow or volume control damper or fire damper, okay, or any accessories, you can able to calculate by using the velocity pressure method. Okay, if I think I have shared this information in the teams as well. What is static pressure, what is velocity pressure, how to calculate, okay, and what is the total pressure method. This also I have shared in the group, so you can able to understand what is static pressure, what is velocity pressure. Okay, so static pressure normally comes in the straight duct. You can see that the definition: static pressure is the pressure that causes air in the duct to flow. Okay, so it mainly causes pressure in the ducting. Okay, and the velocity pressure is the pressure caused by air in motion. Okay, while in motion there are different fittings. Okay, you have an elbow, you have a pressure ducting, duct dampers, you have a different type of louvers. Okay, so when it passes through the fittings, you have a velocity pressure. Okay, so you can able to calculate the velocity pressure, right? So you can able to calculate the equation. Velocity pressure calculation is Vp equal to 0.602 multiplied by V square. Okay, the static pressure calculation FL rho V square by 2G. So okay, all the value you can get it by means of the value is available. Okay, so if you calculating one of the ducting, supply duct, okay, so there is a flow rate and you can enter the size, whatever the size as per your shop drawing. Okay, then you can able to calculate the width and height based on the friction method. Okay, remember I told you the friction. What is the friction you have to design? Okay, so based on the friction you can able to calculate your duct sizing. Okay, there is a software as well available. If you go to software, I have attached a duct sizer. Okay, so if you go to duct sizer, you can able to calculate the friction drop. How much friction drop? Okay, I will just open the software. Okay, this is the one of the McVay software, or any of the tool you can use it. Okay, if you go to metric unit, you can able to enter the liter per second. Okay, and you can enter the size of the ducting. whether it is square or rectangular, you can able to enter. Then you can able to get the pressure drop, how much pressure drop will be there. Okay, so this pressure drop should be within that range. Based on that value, you can enter all the values here. You can feed the values here. Okay, so what is the flow rate, what is the diameter, or what is the rectangular duct. Okay, you can able to calculate the area. Okay, you can able to calculate the length of the duct by using the shop drawings, right? So the velocity you can able to calculate Q equal to A multiplied by V. So the velocity is equal to Q divided by area, right? So you can able to calculate the velocity. Okay, the friction factor you can able to get the values from the software itself. Okay, what is the friction factor, or by using the ASHRAE also you can be able to get the friction factor. So enter the value here. So by using this value you can able to calculate the total static pressure. Okay, F is nothing but friction factor, L is nothing but length of the duct, rho is nothing but air density, which is 1.2, then velocity you can able to calculate the velocity from here, divide by 2. Okay, and diameter means either from the diameter, if you have a rectangular duct you can convert into diameter. Okay, so you can, if you enter the value, you can able to get the static pressure value per meter ducting. If you have a 10 meter ducting, you can able to calculate for 10 meter, right? So this is the static pressure calculation. Okay, and if you want to calculate the velocity pressure, right? Okay, now there is an elbow. Okay, and from the elbow also you can able to calculate the area, you can calculate the velocity, and also you can calculate the loss coefficient from the software. Okay, velocity software, ASHRAE software. Okay, so you can able to enter the values here as per loss coefficient. Okay, then you can able to calculate the velocity pressure, right? 0.602 multiplied by velocity square. Okay, and to calculate the total static pressure drop, you can able to calculate velocity pressure multiplied by the friction factor. You can get the total static pressure. Okay, so by this method you can able to calculate the pressure for the ducting and pressure for the fittings. If you have a volume control damper, the same method. Clear, right? Everyone is clear, right? So you can able to calculate all the fittings. Okay, if you go to any of the shop drawing, you will be having elbow, you have a dampers, you have a volume control damper, or you have a fire damper, or you have all the type of dampers available in your shop drawing. Okay, and the loss coefficient you can able to calculate from the software also, and also you can able to calculate from the directly from the ASHRAE duct design chapter. Okay, how to calculate? If you go further down, okay, there are different type of fittings available here. Okay, say for example, I have one of the fittings which is called elbow. Okay, so this is the round fittings. Okay, if you go to elbow, there is a elbow here. Okay, based on your radius by diameter. This is the radius. What is the distance of the elbow? Radius. Okay, and the diameter. Okay, if you know this two value, which should be normally as per standard, should be 1.5. Okay, then you know the diameter. If you go to the diameter, you can get the coefficient. This value. The loss coefficient you can able to get from the chart also. Okay, if you difficulty to find out from the chart, then you can use the software. Okay, if you go to any of the software, you can get the, say for example, this for the straight duct, you will get the friction factor. Okay, if you go to any of the elbows, say for example, I have an elbow here, or I have a damper. Assume that I have a damper. You will find loss coefficient. Okay, so you will find the fittings here. Say for example, this is CD91, right? So there are different type of fittings. Depends upon the angle. Okay, how much your blade is rotated. If you have a more closure towards the closure, then you have a more pressure drop. Okay, if it is towards open, then you have a less pressure drop. Okay, also you can get it from the, based on the angle, you can able to get the loss coefficient. If you get the loss coefficient, it is very easy to calculate your velocity pressure method to calculate your pressure drop. Okay, so that you can able to summation all the value. We will see differently for the grills and diffuser. I will have a separate video. Okay, first just let us understand how to calculate pressure drop calculation for the duct methods, right? If you go to any other fittings, say for example, I have a fire damper, right? See the directly fire damper curtain type, they have given the coefficient directly here. So you can take the value here, go to the Excel sheet, feed the value here, then you can able to calculate the pressure drop. Okay, and if you go to different fittings, say for example, assume that I have a taper piece. Okay, so taper piece, there is a value given here, A by A1. This is the area of A0 and this is the value for A1. Okay, if you divide by this two value, you will get the ratio. Okay, and then what is the angle of the taper? Then you can able to calculate the loss coefficient value here. It's very simple. Okay, but you no need to, as of now, you no need to do manually, no need to calculate. Okay, there is a software available. Go to that particular whatever the fittings, because you no need to spend time for this, right? Because you will not get any benefit, because this is just to get the values only. Just understand how to calculate, but no need to apply in your day-to-day method. Okay, we have a software here, right? Okay, and if you go to damper, gauge damper, enter the size, damper size, enter the height. Okay, what is the flow rate? Okay, there is a density already in the field, that value is already available in the software, 1.204. Okay, this velocity also calculation based on Q by A. So you can able to cross verify how this value came. You can able to cross verify the velocity pressure. You can able to cross verify this loss coefficient by using the duct design ASHRAE standard, and you can able to calculate the pressure drop by using the same formula, whatever the formulas. Clear, right?
Sir, one question.
Oh, yeah, tell me. Yes.
Related to this diameter.
Okay.
If suppose we have a rectangular one duct.
Yeah, there is. Yeah, tell me.
So
Yes.
how we can kind of convert that area to this diameter?
No, there is a simple formula, right? Pi by 4 b square.
Pi by 4 b square to length into breadth, and we can convert it. That's it, right?
That is the area. Yes. See,
Yeah.
from diameter, calculate the area. Then from the area, you calculate rectangular duct.
Yeah. Okay. Okay.
So it is a simple method. It is a simple
using
method.
rectangular. How we will select this rectangular elbow using this ASHRAE duct fittings?
No, ASHRAE fittings. There is a see. If you go to this particular software, there is a round, right? Right. And if you go to other, there is a rectangular elbow is there.
Yeah, which one will select that?
Your shop drawing, if it is rectangular, go to rectangular. If your shop drawing is circular, you can go to circular. Because if you go to warehouse or different type of warehouse project, they normally go with round duct, right? Okay, and if you go with residential project, normally they go with the rectangular duct.
No, that's not I'm asking. I'm asking which elbow. There is 2-3 types of elbows showing the rectangular.
See, if you go to, okay, I will tell you something. Okay, if you go to normally we use smooth radius elbows without veins, and there is one splitter, there is a 2 splitter, there is a 3 splitter, depends upon the duct construction. Okay, I will tell you that normally we go with the smooth radius. Okay, this other elbows don't see that one because it is for the different type of duct material. If you go to PPR ducting, or if you are going for any plastic ducting, okay, they cannot make a rectangular. What they will do, they will make a different joints. Okay, so that is why there is another type of elbows, but no need to go. We have a GA ducting, which we have a smooth elbow. Okay, so always you can go with the smooth elbow. In the smooth elbow, there are different type of options available. Without veins, 1 splitter, 2 splitter, 3 splitter. Okay, so this particular one, when you add 1 splitter, you can have a inside there is a support. Okay, this construction will change, depends upon the duct size. I think if somebody is working in duct construction, you can able to understand that there is an increase in duct size. You have a more veins. Okay, for smaller duct, you have a different lesser veins. Okay, so this particular detail you can able to get it from the duct construction manufacturer. Normally they used to mention in the duct construction schedule. Clear, right, everyone?